In this class, I'm going to prove very important theorem. If ax square plus 2hxy plus by square 2gx plus 2y plus c represents pair of lines, then abc plus 2fgh minus bg square minus ch square 0, h square greater than ab, g square greater than s. It's very clear. Given is ax square plus 2hxy plus by square represents pair of lines required to prove is abc plus minus af square and another one is f square greater than bc, j square greater than s. So in the last classes I discussed about lines which are passing through origin. Then these lines equation can be written of the format ax square plus 2hxy plus by square. So don't write this in exam, only for understanding purpose I am writing. Suppose two lines are not passing, this is origin, not passing through the origin, then you have like y equal to 2x plus 1, other is y equal to 3x plus 2. So once you multiply it, 3x minus y plus 2 0. So here it is 2x into 3x, 6x square, 2xy plus 4x minus 3xy plus y square minus 2y plus 3x minus y plus 2. After simplification, you get y square plus 4x 7x minus 3y plus 2. That means if lines are not passing through the origin, which can be expressed in the form of 2gx plus 2fy plus, right? So it's a, for examination point of view, you should not write all this. Is only for understanding purpose. That is why I'm putting this in red. Don't write this in exam. Only what I want to say is, if at all there are two lines which can be expressed in this form. So this pair of lines, this expression, if at all it represents pair of lines, one line, general equation form, L2x plus n. So now comparing, let us multiply it. General multiplication, L1 L2 x square and L1x into M2y, L1 M2 xy, L1x into N2, next M1y, M1 L2 xy, M1 M2 y square, M1 y into N2, M1 N2 y. plus this part. I'll write here N1 L2X, N1 M2Y plus general multiplication I did. Comparing like powers, we get here x square coefficient. If you compare L1 L2 is a y square coefficients here M1 M2 is equal to B. Comparing constants N1 N2 is C. Comparing xy coefficient xy here L1 M2 plus L2 M1, which is 2H. Comparing x coefficient, here is x coefficients L1 N2 plus L2 N1, which is here x is 2G. Comparing the y coefficients, y here, y means here M1 N2 plus M2 N1, which is 2F. Now, so to prove the first relation, what I am considering is 2F into 2G into 2H, M1 N2 plus M2 N1, L1 N2 plus L2 N1 into L1 M2 plus L2 N1. So 8 of GH, this we get L1 M1 N2 square general multiplication, this into this L2 N2 M1 N1, this into this M2 N2 L1 N1, this into this M2 L2 N1 square. So totally we get after simplification 8 terms. So this into this, we get L1 square M1 M2 N2 square. This into this L1 L2 M square N2 square. After that, this into this, we get L1 L2 M1 M2 N1 and this into this L2 square M1 square N2 square and this into this M2 square L1 square N1 N2 plus this into this L2 M2 M1 L1 N1 N2. Two more terms. This into this M2 square N1 square L1 L2. This into this M2 M1 L2 square N1 square. General simple multiplication. Now here 8 of GH M1 M2 is here B L1 square N2 square. So where else N2 square here? Here L1, L2 is there A and N2 square. Here L1, L2 is A, M1, M2 is B, N1, N2 is C. Here it is second term L2 square, M1 square, N1, N2. That is C into L2 square, M1 square. N1, N2 is C. Here it is L1, L2 A, M1, M2 B, N1, N2 is C. L1, L2 is A. Here M1, M2 is B. Now, here you have ABC, 2ABC. Here, if you take B common, L1, L2 square, N1, L2 whole square, then A common, M1, M2 whole square plus M2, N1 whole square. Again here C common, L2 M1 whole square, L1 M2 whole square. To ABC plus B into L1 N2 plus N1 L2 whole square, A square plus B square, A plus B whole square minus 2AB. Here it is M1 N2 plus minus 2M1 M2 N1 N2 plus C into L1 M2 plus minus 2 L1 L2 M1 M2. 8FGH is N1 L2 plus L2 N1 is 2G. L1 L2 is A, N1 N2 is C. M1 N2 plus M2 N1 is 2F. 2F whole square minus 2BC. This L1 M2 plus L2 M1 is 2G. Sorry, 2H. 2H whole square minus L1 M2 is A, M1 M2 is B. So it is 4BG square minus plus 2ABC here, it is minus 2ABC plus 4AF square minus 2ABC minus 2ABC. Get cancelled. 4 times BG square plus AF square plus CH square. This is 4ABC after taking 4 common, you get. So from here, ABC plus 2FGH. This is the first condition. Once it represents a pair of lines, we have to prove this. And second condition, what we have to prove is H square is greater than or equal to A. To prove it, consider the difference. H here is L1M2 plus L2M1 by 2. Right? A is L1L2, M1M2, which is L1 plus L2M1 whole square by 2 square after taking just rearranging the terms by 4. It is A plus B whole square minus 4AB, A minus B whole square by 4. Whole square is always greater than or equal to 0. Its square is greater than or equal to. Similarly, G square minus AC. Here G is this L1 N2 plus N2 N1 by 2 whole square L1 N2 plus L2 N1 whole square minus 4 L1 N2 L2 N1 by 4. That is A plus B whole square minus 4AB. So that is G square minus AC is greater than 0. G square is greater than AC. So still what else we have to prove? F square is greater than BC. What is F? F square minus BC. F is what's 2H, right? F is this M1 N2 plus M2 N1 by 2 whole square minus M1 N2 plus M2 N1 whole square. It is A plus B whole square minus 4AB, which is A minus B whole square. Whole square is not negative, means greater than or equal to 0. Right? It is little lengthy theorem, but you have to practice it more of times. After listening, write this theorem 2-3 times on the paper. Then only you will get